Hello, everyone, and welcome to today's webcast, How DCIM Empowers Data Center Operations. I'd like to thank you all for joining us from wherever you may be in the world. My name is Melissa Topp, and I'm the Senior Director of Global Marketing here at Iconics. And before I turn it over to our presenters for today, I'd like to just go over a few housekeeping rules. Right now in GoToWebinar, you're in a listen-only mode. That means if you have any questions at any time throughout the presentation, you can use the questions and answers section of the GoToWebinar panel to type in your questions, and we'll do our best to answer those for you at the end of the webcast. And with that, I'm going to introduce you to our presenters on the next slide. Presenting today's webcast, we have Rick Vanderkooy, Director of Data Center Application Engineering at Mitsubishi Electric, and Martin Matza, Global Business Development Manager at ATS Global. Both have a storied history of working with Iconics data center software solutions, which I'll let them tell you more about when the time is right. First, just a quick summary of what's ahead on the agenda for today. We'll start by taking inventory of what goes into operating a data center on a daily basis. Then Rick will give an overview of Mitsubishi Electric's portfolio relevant to data centers before handing things over to Martin, who will discuss factors to consider for choosing the right data center information management solution and how doing so can improve your day-to-day operations. Martin will also walk you through the key features and benefits of our best-in-class DCIM solution using reference case studies to illustrate how others have benefited from deploying this technology. And last but not least, we'll leave some time at the end to answer any of those questions you may have chatted into us throughout the course of the presentation. So before I turn it over to Rick, we just wanted to start things off with a quick poll to get a feel for what your priorities are as an audience here today. I've just launched the poll, and the question we have for you today is, what is your biggest challenge in the day-to-day operation of your data center? So if you could, please go ahead and look through the options there and pick your favorites or your biggest challenge as we've asked, and give some time for everyone to answer those. I see some responses trickling in here. Come on, everybody. I know it's tough to choose just one, right? I'm sure many of you struggle with several of these, but please do your best to pick your top challenge. We'll give just a bit more time to give everyone a chance to vote. So is it availability and uptime? Is it reducing your overall operating expenses? Is it utilization, power, cooling, space? All right, just a few more seconds here. I'll go ahead and close off the poll. Appreciate those of you who have weighed in already. Great, so let's see the results. So the 31% of you voted that maintaining availability and uptime was your biggest challenge, and that tied with reducing operating expenses, also at 31%. So I'm sure Rick and Martin can speak to that later in the presentation. Again, I appreciate everyone for voting there today. And now, without further delay, I'll turn things over to Rick to get on with the rest of the presentation.
Thank you, Melissa, and thank you all for joining this webinar. Like Melissa said, I'm Rick Vanderkooy, and I joined Mitsubishi Electric 7 months ago as the Director of Data Center Application Engineering. Before joining Mitsubishi Electric, I was working at Interaction, a digital realty company, for 14 years in several roles. And 14 years ago, when I joined Interaction, I took care of the daily operations at the data centers. So I had to help customers with their requests, but also had to follow up on technical alarms, support maintenance activities, and do monthly kilowatt hour reporting for billing purposes. I had to run around the data center a lot to get things done and to understand where alarms come from and what the root cause was. So when we started using the Iconics DCIM solution, it only had rack monitoring in it. And to manage that daily data center operations, I asked Martin for help. I walked around in the data center and I would ask him what else I could connect. So we started building up a library of hardware components on the Iconics DCIM. I had racks, chillers, crack units, the leak detection, generators, battery monitoring, the UPSs, sensors, power meters, the ATAS system, the fire detection system, everything that we could find, let's say, to combine it all into one system to optimize the alarming, SLA monitoring, billing, and reporting functionalities, the PUE and ER management, and incorporated the complete existing EMS and BMS solutions that we already had in our data centers. So the Iconics DCIM gave me an overview of everything in the data centers. And we could create dashboards across multiple data centers as we had many data centers to manage at the same time. It was able to connect with all the brands, all the different vendors, and it's perfect to fit for both existing data centers, so the brownfield data centers, as also on the new data centers, where it will give a total overview of all the components of the data center. And it helped me a lot on improving efficiency, but also hugely improved our billing capabilities. So I didn't need to go every month doing rounds with manual writing down all the values with all the potential manual errors that were there. So it was all automated. And Martin will tell more about it later in this webinar about how to secure that data, make sure that there are no errors in your billing and reporting towards your end customers. But also on just following up on technical alarms. I could see a total overview of data centers. So instead of that, I had to walk down into the data center, go to the device that was giving an alarm, and then figuring out what was going on. I just had to open my DCIM and click through a few pages, and it gave me a complete overview. For instance, if there was a crack unit in alarm, I could immediately see the surrounding crack units, the room temperature, the pressure that was in the room, but also the pumps in the chilled water system or the crack units, hybrid dry coolers, or everything which was feeding into those cold water system. So I could even see the power monitoring on those parts, and that gave me immediately a lot of information that I needed to assess what was going on and determine the first actions to resolve the issue quickly. This resulted in less downtime and less risk of potential loss of services to customers. So it gave me a true real-time overview of every part of the data center. And with the same mindset, I joined Mitsubishi Electric. And a year ago, Mitsubishi Electric decided to start bringing solutions to the data center market. So we looked internally to all of our products and created a complete solution fitting for the data center market. So we can now offer the complete infrastructure hardware for mechanical and electrical sites, and of course our Iconics DCIM as an umbrella system over the complete infrastructure. So if we go around the circle, our offer exists of PLCs and control equipment for electrical and mechanical installations, medium voltage switchgear, our modular and scalable UPS systems, low voltage switchgear, our gensets, and IT cooling equipment like chillers, air handling units, fan wall units, crack units, etc. And of course, as mentioned, our Iconics DCIM on top as our umbrella system. So we ensure complete engineering of our solutions fitting to your data centers, including commissioning and maintenance and service. And so it's definitely a total solution fitting to your needs, and we're engineering it based on requirements of the data center itself. And with that said, I would like to turn over to Martin, who will tell more about our DCIM solution. And of course, if you have any questions about my past, how I manage data center, but also about our portfolio of solutions, please share your questions in the chat, and we'll answer them at the end during our Q&A session. And hereby, I would like to hand it over to Martin.
Okay, Rick, thank you very much. Good morning, good afternoon, good evening, everybody. So my name is Martin Matze, and with an ATS Global, I'm responsible for the data center market. Just one slide about ATS. ATS is an industrial SI. So we are founded in '96. We have at the moment, I think, almost 1,400 people working in 29 countries. And if you look to the left part, you can see in which areas we're active. So from control up till data centers. Okay, about the presentation. So I hope this is you. You are responsible for a data center, and you have some issues. You want to automate your invoices, improve your asset utilization, so decrease the outage risk, manage your capex, opex, improve your performance, and reduce your costs. So those are also mentioned in the poll we had in the beginning. Have information about your energy balance, and you have to comply with new directives and legislation that are coming, like the Energy Efficiency Reporting Directive and the Corporate Sustainability Reporting Directive. So you have some issues, so hocus pocus, focus, conclusion, we have a magic stick. We're gonna need DCIM to do all these things for us. But if you're gonna buy a DCIM solution, what are you going to buy? You have no idea. So what you're gonna do, you're gonna send out an RFP, and with the RFP, there's a compliance list. So at the left part, there's an example of a compliance list. So you try to list all the features you can think of, and you're gonna send them out and ask them, do you comply? Do you partly comply? Do you not comply? Is it optional? And so on. So that's what we did. And we have 3 vendors invited, and we had all those features. And looking at all those features, you can see at the bottom, so vendor number 1 has 8 compliances, number 2 has 9 compliances, and vendor number 3 has 14 compliances. So clearly the winner is vendor number 3. So we're gonna buy the DCIM solution from vendor number 3. But is it really the right solution? If you look to the first line, the invoicing part, all 3 vendors do comply with it. Looking at invoicing, you know, if you're a co-location site, you're renting out racks, people are using power and they have to pay for the power consumption. And that's what you invoice. And if you want to know how much power they have been using, you will take the kilowatt hour value at the end of the month, minus the kilowatt hour at the beginning of the month, times the rate, and then you have to invoice. So in this example, we see a customer who's renting 9 racks and he's using 12,600 kilowatt this month, times 25 cents, which is what you ask for your power. So that's $3,150 altogether. So actually, that invoicing part is very, very easy, and now we get it covered. Oops, do we really have it covered? Did you see it? Rack number 6, it counted down instead of up. So instead of having a plus 1,800, it had a minus 1,800. So on this monthly invoice, we missed 3,600 kilowatt hours. And if you look to the yearly base, we invoice now $37,800 instead of $49,500. So we've lost $11,700 on this customer yearly. That means in this example, that's 13% of the turnover is lost. So we're gonna add just some additional features on this database, and we have this also covered. So we had a small issue, but now we got it right. Another example is coming from one of my customers. He said, Martin, I have the following problem. A customer comes to me and he said to me, I like to rent 25 racks. Can you send me a proposal? So I create a proposal, send it to the customer, and the customer said, well, it's a very good proposal. You're gonna go say yes to it. I make sure I got a signature from my boss, but can we already start? So the salesperson sends a proposal to the operations, and they release 25 racks, and the customer starts using 25 racks. But when the proposal is signed, his manager said, well, we're not going to need 25 racks in the beginning, so let's start with 15. So he signs for 15, send it to the salesperson, and that's sent to the finance department. So what's happening here right now, that they are using 25 racks, and they're only paying for 15 racks. So they're missing 10 racks. This happened quite regularly, by the way. Another example, so this is a new data center. You can see at the left part, there's a PDU. PDU stands for Power Distribution Unit. You see the power division and consumption, and every rack has one PDU, also a PDU, by the way. It's a little PDU in the rack. It's quite straightforward and very easy. But in the data center, there are changes every day. So after a while, the same data center looks like this. So the first rack has 2 feeds, the second rack has a 3-phase feed, and the third rack has even 3 customers. And a part of the customers are coming from another PDU. So you can imagine during all those changes are done manually. It's quite likely that somebody will make a mistake. So this is just a list of mistakes we have found in the invoicing part. So the first one you've seen, the miscommunication between sales and operations and finance. But then looking to the power meter, there's so many things you can do wrong on a power meter. So it's not rightly configured, it's not rightly connected, it's not attached to a rack, it is a wrong type. So they can have a very big error. They can sometimes have a small negative step in kilowatt hour values. That's a reachability issue. Sometimes there's a big positive or a big negative step in the month. So it can be a replacement of a power meter, communication lost. Sometimes we see that just one current transformer is installed upside down. That means you're going to lose 60% of your reading. It's not connected to DCIM. And of course, then you have all those changes through the month. So when you look to a running data center in general, you can say they were losing 5 to 10% of the turnover, and sometimes even more, due to all these issues that do occur. Just realize that a general power data center has around 30,000 power meters installed. And of course, if a customer will find out that invoicing are going wrong, they're going to lose trust and they're going to leave. So in our system, we got many ways to check it. This was just one example. So these are 2 bus bars, the A and the B bus bars with 3 feeds. And what we, for example, do is we look at all the separate installed PDUs on the bus bar, we add them all up, and we compare them with the main power meter. So the difference should be 0. And if not 0, there's an error. And the same is true on the right bottom part. You can see a red rectangular. That means there is no customer using this rack, or at least there's no customer contract attached to this rack, but he's still using power. So if you have to create invoices, you don't have to check all these small steps. So what we do, if you look to our system, we can attach the CRM system containing all the contracts to our system, and that's again attached to finance. And then at the end, you got a report like this at the bottom, and all the green bullets are okay, and on the red and the yellow bullets we have some issue, and only for them you have to drill down and look back what has been going wrong. So the PUE, Power Users Effectiveness, tells you something about data center efficiency. So this is a table coming from the Upstream Institute, and if you look to the left part, in 2007, the general average worldwide PUE was 2.5. That means that at that moment, even more power was going to infrastructure than to IT. Then they started to improve, and at the year 2013, it is 1.65. And what we see since then, that is more or less flatlined. So now the last report that came out about a month ago, the worldwide PUE is 1.55. You see that we didn't improve anymore. And why is that? The reason is actually that the biggest impact on improving was just cold or hot air containment. And after that, most data centers had no good idea how to improve anymore, beside of just buying a little bit more efficient equipment. So looking to the right part, what is the most important for data centers? It's total power consumption and it's PUE. So it's all about money. So if you look to our system, of course, we also included the PUE, and we can see the PUE in real time. But what does it bring, this information? So again, this is based on a true story about improving PoE. So there's a data center, they had a PoE of 1.46. And then the local administration said to the data center CEO, your PoE has to be below 1.3 because that's the regulation which on our area within 12 months. And at the moment you're at 1.46, which is not good. So the CEO went to the facility manager. He said, you have to improve our PoE because it must be below 1.3. So you have the coming months, that's what your task is. So if you look to the drawing at the right side, that's the data center. So they have 2 data rooms and they're using a total 4 megawatt. And at the right side, you can see the PoE is 1.46. If you look to the green grid, they also have a PoE decomposition. So if you look to the partial PoE of room 1 is 1.25, the partial PoE at room 2 is 1.62, and the general, which actually is the infrastructure part, in the general part is 1.7. So the facility manager to the CEO says, well, my EMS tells me that our best part of the PoE is 1.3 and the worst part is 1.6. So what can I do? We already did called our containment and our cracks are optimized via our control vendor. I know the design PoE is 1.25, but that is at a really completely filled data center. So if you want to improve your PoE, you really should increase your load. So it's up to sales. There's actually nothing I can do. We did all we could do. Well, actually, if you look to this number and having this as information, I can imagine that he is saying that. If you want to know more, you really need one integrated monitoring system. So all the components, energy, cooling, building, everything together into one system. And having all this information complete, you can do something with it. So again, looking at this data center. So this is the data center. At the bottom part, the PoE is 1.46 and the target is below 1.3. And you can see that the room 1 is a little bit too high, room 2 is even further too high. Looking to the other parts, you can see that the EER, which is the energy efficiency ratio, which tells you something about cooling, is quite low in room 2. That should be improved. I can see that my capacity is quite low. And what really scares me is at the top, I have lost my redundancy on my cooling. So in room 1, I have an 83% load, which is way too high. So actually, regardless of the PoE improvement, step 1 I'm gonna take is to get rid of this redundancy issue. Now I can do several things. I can buy more cooling equipment, that is one. But what I also see is in room 2, I have more than enough space. So I agreed with some customers that I'm allowed to move some of the IT equipment from room 1 to room 2 to get rid of this N+1 issue, this redundancy issue. So that's what I did. I moved now part of the equipment from room 1 to room 2. You can see I got my N+1 back, so I have my redundancy back. But in the meantime, what has happened, my EER of this room has been improved. So now my EER is even above 7. So just by moving IT, I improved my efficiency, I have my redundancy back, and I also have a big impact on my PoE. Because if a crack unit's load is going down, in general, efficiency is increasing. So I'm just slightly above 1.3, quite close. Now looking to my UPS part, I see 2 things. The efficiency is quite low, but also my load is quite low, and there is an imbalance. You can see it 35-27 on the different feeds, so it's not very good balance. So that's the next step I'm going to take. Looking to the UPS, you can remember it was just above 40% load. The efficiency is going down. So when a UPS starts to become efficient if it has a load above 70%. This is, by the way, just a trend from the Energy Star. Of course, you can buy a more efficient UPS. You can buy a Mitsubishi UPS, so the curve will go up, but still the form will remain the same. When a UPS has a low load, it will decrease its efficiency. So now, if you have a good monitoring system, you have seen that we have very low load, so we're going to get rid of some batteries. And just by doing that, the efficiency starts improving. And the next step that I saw an imbalance. And an imbalance, it is also shown below, results in zero currents, and zero currents will result in losses. So Also, by balancing the load on the UPS, it's an improvement step. So doing those two things, having smaller UPS capacity and balancing the load, also increased the UPS load utilization and improved its efficiency. And now by these two steps, I brought my PUE below 1.3. And you remember in the beginning when the CEO was having the discussion with the facility manager, he said, there's nothing I can do. Sales should be doing something. Sales should be sell more. It was actually not true. He could have done a lot if he had had the right information available. So what does it bring? So show me the money. Just an example, co-location site, 12,000 square meter using 15 megawatts. They buy the energy at 10 cents per kilowatt. And if they have a PUE of 1.46, the yearly energy cost is $13 million. If they're going to decrease that PUE from 1.46 to 1.25, the energy consumption is going to be decreased from 15 to 12.8 megawatt. And then the total energy cost will be 11 million instead of $30 million. So that will bring $1.8 million yearly on energy consumption reduction. The other part is the missed turnover due to faulty invoicing. So if you're selling your energy price at 25 cents per kilowatt, and based on this numbers again, 15 kilowatt, PUE 1.46, you have an energy consumption on IT of 10 megawatts. So your turnover will be $22.5 million. But in general, if you miss 5 to 10%, you are missing something between 1 and 2.2 million yearly. So let's assume it's just in the middle. In that case, we miss almost $1.7 million. So just do those two steps, improve in efficiency and make sure that your invoicing is right, bring you $3.5 million yearly, which brings in the ROI of a DCIM solution just up to 2 or 3 months. So the message is, if you're going to buy a DCIM, it's not about counting the number of features which are available, but it's about knowing what you want, knowing what you need, and understanding your operation to improve them and support it. And of course, you're not going to buy a DCIM solution because of the nice to have things, but based on real ROI items. So in this example, it's about invoicing and contract management. Sometimes it's SLA management, performance management, asset utilization, preventing outages, reducing maintenance, reducing needed stuff, and of course, quite often, alarm management. But my question to you is, what are your needs? So your DCIM solution should fill in your gaps and your needs. But don't forget to train your people, because just buying a system doesn't bring you the solution of everything, but you have to really understand your own operation and what do you need. If you look to our solution, our iconic Mitsubishi solution, so it's just one system, and we see at many competitors that they have a system for cooling or BMS and a system for power. And if you remember the Bella scorecard, you see that you need all that integrated information to tell you the complete story. Well, we have a complete integrated system, and we also have this analytical add-ons like performance, capacity, and invoicing management. It's open, it connects to any device, regardless of protocol or brand. So we don't need hardware, PLCs in between to get it interface running. It's scalable. If you look to our customers, the biggest part of our customers are either medium-sized or big sites. So at the moment, our biggest customer is on one side, as it has 75,000 assets, so even more than this. It's over 1 million data points and has 30 users, and it's very, very scalable. But what is our real secret? Our real secret is the way we create the application for you. So we have a rapid development tool. We call it Project Builder. In this rapid development tool, we have over 1,400 different building blocks available. And just one power meter from Mitsubishi is just one building block. And we have over 1,400. And if you want to deploy that power meter into your dish solution, you just have to know which brand, which type, and what's its IP address or what's its Modbus address. And then you generate the building block into the application. Just to give you some idea, is we have that rapid development tool that creates objects, that creates displays. And looking to Schneider, for example, we have 68 different Schneider devices available in our system, and we have deployed them 168,000 times. So it reduces a lot of time. It's repeatable, and we have also version control. So just some graphics, white space management with recs and cracks and so on. A single line diagram, cooling management, and at the end, just two examples of customers. This is LCL. LCL is a data center group in Belgium. At the moment, they have five locations, and they monitor all those 5 locations from one system. So it's an integrated system, and all the customers are attached to the same system. So regardless where the customers are, they can generate invoices based on their power consumption. So if you go to the LCL site, so you can find a story about us. And the other one is the company from where Rick was coming, so Interaction, the digital realty company. I think we did around 20 sites of them, and there's an article in controlengineeringeurope.com, so you can find the article back. And if you're really interested, I think we can send you the link for this article. Just some customers. We have some very interesting customers, I think, like BT, Microsoft, Amazon, Vantage, Equinix, Digital Realty. So we also have quite some interesting names added to our list. Okay, this is my presentation. I think it's now back to Melissa.
Thank you so much, Martin, and thank you to everyone who submitted questions during the broadcast today. If you haven't sent yours in yet, now is the time. Just type into the questions panel and go to webinar. All right, so the first question is, and I'll let Rick and Martin fight it out as to who should answer. What is the main difference between your DCIM solution and the competition?
I'll leave that one to you, Martin. Yes.
Okay. Yeah, it's always very difficult, I think, to compare our solution to the others, because we can compare our solution to vendor A, vendor B, vendor C, but if you compare it to the general group, it's more difficult. But I think if you take an overall picture, it are 3 things. I think one of them is the rapid development tool. That's unique. I think we're the only one. And this rapid development tool is a tool we are using to deploy projects. But the rapid development tool is also available for our customers. So if you buy our system, you can be also using this tool. It's the fact that it's one system, so it connects to anything and every part. It is power, it is cooling, it is building, but it also integrates to CRM, maintenance, ticketing, and we have some very interesting optimization tools. We didn't show you right now AI tools for white space optimization, but also to optimize from room to roof. So we have a very complete DCIM suite. So I think taking that all together, the combination of things is quite unique.
Yeah, and to add on that, as coming from the customer side, for me, what a big differentiator was and a big success on it is the ability. Well, what Martin said, of course, is to have one view, one umbrella system across the complete data center, so everything incorporated from fire detection, leak detection, electrical and mechanical areas, but also the ability to adjust it to my own needs. It's really flexible in that way.
Great stuff. Thank you both. So the next question we have, how fast can you deploy your system into an already existing data center? Rick, you want to take that one?
Yes, I would. Yes. So if you look at our implementations, okay. So if you look to the implementation we did, so the example that Rick was mentioning, we started at Interaction as a brownfield, so that's an existing, and then after that we did many greenfields. I think the most difficult part in a brownfield data center is that not all devices are able to communicate from the beginning. So sometimes you have to buy some additional hardware, some communication cards. But as soon as they are online, we can have a very fast deployment. So in general, we can deploy a complete DCIM suite in 2 or 3 months. given the fact that everything is able to communicate on any communication protocol, whether it's BACnet, Modbus, SNMP, OPC, whatever. So that's the biggest step is getting them physically connected to the IP network, and after that, it's a very easy and fast way to deploy it.
Yeah, as long as your administration is in order, then it goes very smooth. And administration on which device is where in your data center, which IP fits into it. That's,
and that's something else that's quite nice. I think in general, if you look to some of the competitors, they need a lot of PLCs. And in that case, the design of your communication network is vital to set up the communication. In our case, we don't care because everything, it just has to be on the network somewhere. It can be on either through a PLC or either directly connected. So it's very easy just having to know what it is, what its IP address is, and where it is somewhere in the data center enables us to show it and to integrate it on the DCIM solution.
Okay, then that sounds great. Next one. How many different brands, so along the lines of that connectivity, how many different brands and devices do you already offer connections with or to?
That's a lot.
Yeah, that's a number.
I mean, the general brands that we are already connected to, and I think on device level, it's of course a lot more, but we've connected to Siemens, Honeywell, Schneider, Mitsubishi, of course. Those are the main brands, but also smaller brands for leak detection, for instance, CTK, for fire panels. There's a couple actually. Can't remember anymore which one. And on device level, it's pretty much every device that you see in a data center, from a single sensor point that's just measuring the pressure or temperature somewhere, till up to generators or chillers or UPS systems. So
yes.
the amounts, you probably have a small view on amounts, right, Martin?
Yeah. I remember I saw the 1,400 different individual types, and if you looked at the number of brands, it's somewhere between 40 and 50 brands we already connected. So I can say that well, every brand in the data center we have some connection to. So it's not, that's very, because the platform is very vendor and protocol independent. And if you look to the OPC part, so we have an OPC connection, and OPC also supports, maybe you know better than me, Melissa, but a couple of hundred different protocols even. So yeah, so it's very, I've never come across a device we could connect to our system. And yeah, at the moment I say 1,400, 40, 50 brands, something like that. Yes.
And still counting, of course. Every time we find a new device that hasn't been connected yet, our engineering department looks at how to incorporate it and connect to it.
Yeah, add it to the list. So I guess suffice to say, if you have a question about whether the solution can connect to your equipment, just send it in to us, and we'll let you know. We'll try it out. Next question. So getting a little more specific, someone wanted to know, relevant to Mitsubishi Electric, could you name some of the kinds of devices that are already available that work directly with Iconics within data centers? I guess would be good to limit it to in this case.
So was it apart from Mitsubishi Electric or
specific to Mitsubishi Electric equipment? Yeah,
pretty much every device that we have in our solution towards data centers can connect to the Iconics brand, the Iconics system.
Yeah.
Fair enough.
And don't forget, because Mitsubishi is also having other brands for cooling, clean of data, and RC cooling, and they also are part of the library. So we also connected them.
And even outside Mitsubishi Electric, Mitsubishi is a very large company, of course. And next to Mitsubishi Electric, there's also Mitsubishi Heavy Industries, which are supplying the engines for our generator sets. And also there it's completely incorporated. It's able to connect to it, to the
Thanks very much. Yeah, let's see. I think this could be the last question, unless last call for any other takers. But Martin, here's one for you.
Okay, sorry.
Suppose they deploy your solution. What are the possible next steps to optimize?
Yes. So of course we have that interesting tooling available, which I already showed you. But the next steps are we also are quite active in the AI domain. So we have a digital twin engine, and the digital twin engine is the next step of machine learning. So it's machine learning together with a physical rule set, and you can use that tool to create a real-time CFD, but you can also create what-if scenarios. And the nice part of what-if scenarios is using digital twinning, you can ask questions outside data he's ever seen. So you can ask him questions like, what will happen if this crack will fail? Or what will happen if I lower my temperature? Or what will happen if I add more power? So that's one tool. And the other tool is just that we get all the data out of the engine, and we put it in the AI machine. And that is really going to look at the installation and what goes wrong and what's less optimum. So it's actually the next step. It gives advices on how to improve based on the data that's gathered by the system. So there's really we have some AI implementation on that. I think that's a very interesting part. And next to that, in general, we did so many data centers already. So we also have a lot of knowledge about how to optimize, what the risks are, where it can go wrong. So also our people can help you just by making simple next steps to optimize. So there are several ways in taking next steps.
Yeah, of course, it's also depending on the maturity of your data center and of your team. It's looking at real small optimizations to really big optimizations. Even if you think, well, our data center is really already optimized, we still have ways to further optimize. But also for your day-to-day operations, we can give more insights, help you with specific dashboarding for your day-to-day operations. So it's really depending on the maturity of your current data center and operation department.
Yes, you're right. But if you look in general to data centers, you can see there is a control for the chiller part, and that is controlling itself. And then the crack units or the CRAS or the air handling units which send on the white space also are controlling the white space autonomously. And that is just an example where we can have big differences, because those are seldom optimized. So a CRA unit says, okay, this is my inlet temperature, this is the maximum return temperature, and he controls on that. But just combining that kind of things together can bring a lot of more efficiency to your data center.
Alrighty then. Thanks so much, both. That's it for our questions for today. So if you do think of any others, feel free to follow up with us via email. You see the contact info for both our presenters there on this last slide. So as a quick reminder, before we wrap up, all our upcoming and on-demand webcasts are listed at iconics.com/webcasts. So I'd encourage you to check those out and sign up for more today. And with that, I'd like to thank our presenters, Rick and Martin, for their presentation. And I'd like to thank everyone who joined us here today. We hope to see you soon again on a future webcast. Thank you very much, everybody.